Interstellar travel is always a dream for our mankind. Due to the large distance between the stars, interstellar travel has always been a dream. Interstellar travel would be much more difficult than interplanetary spaceflight. Whereas the distances between the planets in the solar system are less than 30 astronomical units, the distances between stars are typically hundreds of thousands of astronomical units, and usually expressed in light years. Because of the vastness of those distances, non-generational interstellar travel based on known physics would need to occur at a high percentage of the speed of light. Even so, travel times would be long, at least decades and perhaps millennia or longer. The nearest star to Earth, which is also home to a small rocky world, is Proxima Centauri, which sits a little less than 4 light-years away. Imagine making a scale model of our solar system. Let's say in that scale model you put the Earth 3 feet away from the Sun. In that scale model, Proxima Centauri would sit about 200 miles away. It took one of our fastest spacecraft, New Horizons, traveling 36,000 miles per hour nearly a decade just to reach Pluto. If it were pointed at Proxima Centauri, cruising at that speed, it would get to visit our nearest neighbor in about 25,000 years. The New Horizons mission is helping us understand worlds at the edge of our solar system by making the first observations of the dwarf planet Pluto and by venturing deeper into the distant, mysterious Kuiper belt, a relic of solar system formation. One proposed for an interstellar spacecraft is called the Starshot initiative, which aims to shoot a super-powerful laser on a light sail, using the energy from the light to propel the spacecraft to 1/10 the speed of light. The Starshot could weigh no more than a paperclip. That would enable it to reach Proxima in less than half a century. To make this work, the laser would have to use all the energy from every single nuclear reactor in the United States at once. And it would have to operate for 10 minutes, which is about a quadrillion times longer than we've ever operated our most powerful lasers. Nothing about the Starshot is physically impossible. Just really difficult and expensive, and using technology that is decades, if not centuries, away from coming to fruition. The speeds required for interstellar travel in a human lifetime far exceed what current methods of space travel can provide. Even with a hypothetically perfectly efficient propulsion system, the kinetic energy corresponding to those speeds is enormous by today's standards of energy development. Moreover, collisions at those speeds, by the spacecraft with cosmic dust and gas can be very dangerous for both passengers and the spacecraft itself. Distances between the planets in the solar system are often measured in astronomical units, defined as the average distance between the Sun and Earth, some 1.5 times 108 kilometers, some 93 million miles. Venus, the closest planet to Earth, is 0.28 astronomical units away during its closest approach. Neptune, the farthest planet from the Sun, is 29.8 astronomical units away. As of January 19, 2021, Voyager space probe, the farthest human-made object from Earth, is 152 astronomical units away. In contrast, Proxima Centauri is approximately 268,332 astronomical units away, or over 9,000 times farther away than Neptune. These instances make interstellar travel far more difficult than we think. The fastest outward-bound spacecraft yet sent, Voyager 1, has covered 1/600th of a light-year in 30 years and is currently moving at 1/18,000th the speed of light. At this rate, a journey to Proxima Centauri would take 80,000 years. The velocity for a crewed round trip of a few decades to even the nearest star is several thousand times greater than those of present space vehicles. This means that due to the v-squared term in the kinetic energy formula, millions of times as much energy is required. The crew of an interstellar ship would face several significant hazards, including the psychological effects of long-term isolation, the effects of exposure to ionizing radiation, and the physiological effects of weightlessness to the muscles, joints, bones, immune system, and eyes. There also exists the risk of impact by micrometeoroids and other space debris. These risks represent challenges that have yet to be overcome. There are 59 known stellar systems within 40 light-years of the Sun, containing 81 visible stars. The prime targets for interstellar missions are Alpha Centauri, Barnard's star, Sirius, Epsilon Eridani, Wolf 1068, and so on. Slow interstellar missions based on current and near-future propulsion technologies are associated with trip times starting from about 100 years to thousands of years. These missions consist of sending a robotic probe to a nearby star for exploration, similar to interplanetary probes like those used in the Voyager program. Another type of propulsion has also been proposed. It's the ion propulsion. In an ion propulsion, electric power is used to create charged particles of the propellant, usually the gas xenon, and accelerate them to extremely high velocities. Several concepts have been developed, but none of them has reached the developmental phase due to the cost of manufacturing involved in it. The truth is that interstellar travel and exploration is technically possible. There's no law of physics that outright forbids it. But that doesn't necessarily make it easy, and it certainly doesn't mean we'll achieve it in our lifetimes, let alone this century. Interstellar space travel is a real pain in the neck. And we have reached the end. Tell us your thoughts in the comments section, and if want to receive continuous information from us, then subscribe our channel, which is absolutely free.